What? How did they know
Mine
that?
is
How do you know?
our math exam is my side is one.
Bottom third.
Right, parallel and perpendicular lines. Above the word parallel, draw two parallel lines. Above the word perpendicular, draw two perpendicular lines. Now chances are you've heard the word parallel before. That means that they go exactly at the same slope. Perpendicular might be a word that you haven't heard before. Perpendicular are two lines that are exactly at 90 degrees to each other. So that's why I have a little black box in there to show that that angle is 90 degrees between the two. And the first statement there is kind of an obvious statement. Should make sense to you. If two lines are parallel, they would have exactly the same slope. So we can tell that y equals 3x plus 5 and y equals 3x minus 3. You can look at those equations and you can say to yourself, I notice that they're in the y equals mx plus b form. So whatever is in front of the x will be my slope. And since both of these have a 3 in front of the x, they both would have a slope of 3 and they would be parallel. If we went to graph these to show, okay, I'm going to graph the first equation in green, and I'm going to graph the second equation in blue. If I went to graph the first equation, we've learned this is a relation. There's so many different ways to show a relation. We can show a relation as an equation, as a graph, as a table of values, as coordinates. And so in order to show this green line as a graph, I might want to make a table of values. I might want to make some points to figure it out. Because it's in y equals mx plus b form, the b is my y-intercept. So I would know on my green graph, 1, 2, 3, 4, 5, I already have 0, 5. Because the slope is 3, I know that I can go up 3 over 1 and find another point. Or down 3 over 1 and get 1, 8, or negative 1, 2. I could also find the points 1, 8 just with a table of values. Can you see for the green one? When you plug in 0, you get 5. When you plug in 1 for x, 3 times 1 plus 5, you would get 8. If I plug in negative 1 for x, negative 3 plus 5 is 2. Those are the same points that I found with my slope. You have options. The shortcut is probably using the slope. That's probably the quickest way to find other points. But you can plug in values always to find it as well. And it's nice to have more than one option because you can use that to check. So for the blue one, I'd probably use the shortest way. I would notice that my y-intercept is negative 3. And then a slope of 3 means a rise of 3, a run of 1, rise of 3, run of 1. I would get the point 1, 0, 2, 3. And when we draw this, depending on how straight I can draw lines, do they look somewhat parallel? Yes. Can you see that you could have also, for the blue one, done a table of values? When you plug in 0, you get minus 3. When you plug in 1, 3 times 1 minus 3 is 0. When I plug in 2, 3 times 2 is 6, minus 3 would be 3. And I get those same points that I did with the slope as well. Are we ready? Yes? So perpendicular lines will hear that the slopes are negative reciprocals. think you know what negative means, but reciprocal isn't as easy a word. A reciprocal of a fraction is just flipping that fraction. So the reciprocal of 2/3 is 3/2. The reciprocal of 5/7 is 7/5. And so if we notice the slopes, and again, both of these are in y equals mx plus b form. In this green one, can you see that your slope is 2/3? And in this blue one, my slope would be -3/2. Can you see that one is positive and one is negative? And can you see that the fraction of one is flipped in the other one? So that flipping is a reciprocal, and because one is positive and one is negative, we would say that the slopes are negative reciprocals. If we graph this, you're going to see why they end up being at 90 degrees. Okay, so first of all, the green one. Again, I would probably start with my y-intercept at 0, 1. And since my slope is 2/3, my rise is 2, my run is 3. Rise is 2, run is 3. So I would get the points 3, 3, and 6, 5. Again, you could double check those with the table of values. Can you see though that your table of values, now you're dealing with fractions in the math, is a little bit trickier. Using the slope and the y-intercept makes graphing this quicker. On our blue graph, we have a y-intercept of -2. So I can label that point. Now my rise is 3/2, and remember that slopes that are positive, so the green line has a positive slope. If you're going from left to right, positive slopes go uphill. Negative slopes, if you're going from left to right, go downhill. So this -3/2, when you do rise over run, you can choose your rise to go up or down. It really doesn't matter. So if I go up 3, I'm going to need to go 2 to the left. If I go down 3, I need to go 2 to the right to make sure that my slope is going negative. So the points I could label on here, I have 2, -5. I have -2, +1. And I found those by going rise over run, up 3/2, down 3/2. And can you see from the diagram that we're perfectly 90 degrees at that point? So when the slopes are negative reciprocals, the two lines will always cross at 90 degrees, and that's the definition of what perpendicular means. So if something were parallel to y equals 4x minus 2, it would have the same slope as that green line. Put a green box around it. Do you know the slope of that line? Yes, it's in y equals mx plus b form. The slope would be 4. So the answer to our question, what's the slope of our line? The slope would also be 4. And the parallel lines are almost like too easy because it's always the same number. But do you see how I figured out the slope of my first line, and then I still have to make a statement to show that I understand that it's going to be the same thing, that the slope would also be 4 for the other line. In the second one, call this line the blue line, because it makes sense that the slope of this line is -5. perpendicular line isn't going to be the same. It's going to be the negative reciprocal. So can you see that the slope of the blue line is positive? Is negative. So our slope is going to be positive. Now, this one is confusing because it's not a fraction, but you can make it a fraction. How can I write 5 as a fraction? I could write it as 5 over 1. So when I do the reciprocal, I'll get 1 over 5. So I need to flip the fraction. And since the original is just a number, I can think of it as a fraction as 5 over 1. And then I still can flip it to be 1 over 5. And since the blue slope was negative 5, my perpendicular one will be positive 1 over 5. So we have the idea of negative reciprocals there. Question? No. No? Okay, go to the next slide. Everybody's ready? Okay. There's a symbol in there for parallel. Find an equation of a line parallel to that line and passing through -1. Now the setup that we've done so far in our other questions will also help us with this question. When you see a question that says, find an equation of a line, every time we've had to find the equation of a line, I said, you need 2 things. What are those 2 things that you need? You need the slope, and you need a point. Okay? So then we read the question to see if any of this information was given to us. Does it anywhere say the slope is blah, blah, blah? No. But what does it say? It says that it's parallel to this line. Can you see that this line, I'll make a green line, can you see that you know the slope of this line because it's in y equals mx plus b? Its slope is 3 over 5. So now do we know what our slope is? Also 3 over 5. So they disguised how they gave us the slope part. It wasn't a very good disguise, right? It'd be like me coming to class with a hat on and like, do you guys recognize me? You're like, yes, Mr. Taylor. Disguise wasn't very good. So we've got our slope, and look, they gave us a point. That was given to us. -1, 3. And we have to find it in general form. So when you have a slope and a point, your starting point is either y equals mx plus b or the point slope form. Both are going to be fine. I'm going to use the point slope form this time. So I'm going to use y minus, this is my y1, oh sorry, x1, this is my y1. It'd be y minus 3 equals m, which is 3/5, x minus a -1. So I plugged it into my point slope form. We want it in general form. So general form has no fractions, no brackets, everything over on one side equal to 0, and the a value positive. So first of all, I'm going to get rid of the brackets by distributing. 3/5 times x will be 3/5 x. 3/5 times a +1 will be plus 3/5. I have fractions. I'm going to take this whole thing and multiply the whole thing to get rid of the fractions by 5. On the left-hand side, can you see that you have to distribute? You would have 5 times y, which would be 5y, 5 times -3, which would be -15. When I multiply the first term with a fraction by 5 and the divide by 5 would cancel out. And same thing with the second one, the 5 and the divide by 5 would cancel out, giving me 3x plus 3. My a value is positive, so I'm going to move the 5y over to this side. I'm going to add the 15 to both sides. So I have this side equal to 0. I have 3x minus 5y. 3 and 15 are like terms. And we changed it to general form. So when a question asks for general form, you can never write the general form directly. Right? You have to either start with the y equals mx plus b or the point slope form and manipulate it. So when you have your slope and your point, you can start with y equals mx plus b and find b, or you can start with the point slope form and plug things in, and then manipulate from there. So that hasn't changed. So basically what we're doing today is we've added parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines, the slopes are negative reciprocals. And we're still going to do the same questions that we did the other day, which was find the equation of line. And the two things you need to find for an equation of line are the slope and one point. But now it's just going to be more disguised how we tell you the slope. Like this one, the question didn't directly tell you the slope, but it told you that it was parallel to that green line. And that green line was in y equals mx plus b form, so we knew the slope. How could I make this question a little bit harder? What happens if I gave you the green line in general form? If the green line was in general form, can you see that you would have to first change the green line to y equals mx plus b to find its slope? And then you could say, I know the slope, I know the point on my line. So the questions aren't going to change just how we disguise how you find your slope. It's pretty hard to disguise how you find a point, but sometimes they disguise that as well. So we're going to look at a couple more examples. Okay? This is the symbol for perpendicular, an upside down T, which is 90 degrees to each other. So again, they gave us a green line. What do we need? We need our slope, and we need our point. And there will always be something in the question that tells you these things. Well, it passes through 3, -5. They did not disguise the point very good at all. But can you see that the slope of our green line is 4/1? If our line is perpendicular to that, then our slope will be exactly -1/4. The fraction will flip, and it will be the opposite sign. So if one is positive, the other is negative. If one is negative, the other is positive. That's what it means to be negative reciprocals. So now that we have this, because the question wants it in slope-intercept form, I would probably start with y equals mx plus b. I know my slope is -1/4, and I know that when x is 3, y is -5 plus b. The only thing I don't know is b. Multiplying fractions, right? This is 3/1. How do you multiply fractions? You multiply the tops. Multiply the bottoms. If I want to get b by itself, I would have to add 3/4 to both sides. In order to add fractions, I need a common denominator. Negative 5 is negative 20 over 4 plus 3 over 4 is equal to b. So my b value is negative 17 over 4. And now I can write the equation because I know that the m is negative 1 over 4, and I know that the b. That's too fast? All right.
You got 3 points by times in negative 3. And the fractions?
Yeah. So I got. So the question was, how do we get this negative 3/4? We get that by multiplying those together. How do we multiply fractions? A 1 times 3 is 3, 4 times 1 is 4, and since that fraction is negative, it would stay negative.
How did you get 4 to negative 1 over?
So in the green equation, that slope is 4. And the question says we need to find the equation that's perpendicular to that. So if it's perpendicular, it won't have the same slope. The slope will be the negative reciprocal. So if the slope of the green one is 4 over 1, the slope of our equation will be negative 1 over 4.
Oh, I see.
So using the y equals mx plus b method, you have to find out what b is. So I plugged everything into, notice how I plugged everything into y equals, I plugged everything into y equals mx plus b. I knew m and I knew a point, so I could plug the point in for x and y, and I plugged in the m for m. And then the only thing I didn't know was b.
How do you use that one?
So when I added 3/4 on both sides in green, I'm going to have to add fractions. How do you add fractions? You need a common denominator. So I changed this minus 5. I needed a denominator of 4. Minus 5 is the same as minus 20 over 4. And I needed that common denominator in order to work the fraction. So technically, right, technically this 5 is 5 over 1. If I want a denominator of 4, I need to multiply the bottom by 4, which means I have to multiply the top by 4. That would give me negative 20 over 4. Perfect? So then here, I'll circle it. Once you found your b value, you can write your final equation. Your final equation should have a number in for the m and a number in for the b, if it's in slope-intercept form. Question? Yeah. Are we ready for the next one? Okay, here we go. Find the equation of a line. So I know that I'm going to need my slope and a point. This is very similar to the last one, isn't it? Okay? Can you see that the point is not disguised at all? It goes through that point. They didn't tell us the slope, but they gave us this green line, and that green line, you know your slope is negative 2 over 3. Our line is perpendicular to it, so what will our slope be? Positive 3 over 2. This time I'm going to use y minus y1 equals mx minus x1 formula. So I know that y1 is negative 3. I know my slope is 3 over 2. I know that x1 is 1. Plug that all in. I can distribute my 3 over 2. And we want general form. General form has no fractions and positive x value. So I have fractions here. So I can put this whole equation in brackets and I need to multiply it by 2 to get rid of the fractions. That will give me 2y, 2 times 3, that'll 6. Here the 2's will just get rid of the fractions, become 3x. Here the 2's will just get rid of the fractions, become minus 3.
And it's plus 6. Oh, no,
And since the x is positive already, I'm going to subtract 2y on both sides. I'm going to subtract 6 on both sides. And minus 3, minus 6 are like terms. Will give me minus 9. So different from the last one. Last one we used y equals mx plus b. You could have used y equals mx plus b on this one as well. That would have been perfectly fine. And then change it to general form. So this, when they tell perpendicular, the slope is a little bit disguised, right? Oh, I like this one. The point is a little bit disguised, and the slope is really disguised. Ooh. Okay, again, what do we need? We need the slope, and we need a point. It's perpendicular to this line. But I can't see the slope of that line easily because it's in general form. So I'm going to do work in green because I'm working with the green line. I'm going to change 2x minus 3y plus 5 equals 0 Why would I want to change it to y equals mx plus b form? Because then I could find the slope. If I want to change it to y equals mx plus b form, notice that we have to get the y by itself. So can you see that you could start to get the y by itself by moving the y all by itself on one side? If I add 3y to both sides, then you see that the 3y would be all by itself on the right-hand side. Now, technically, I should probably write it as 2x plus 5 equals 3y, but when things are equal, x equals 5 is the same as saying 5 equals x. So this next step, are you okay if I write, show my green line, 3y is equal to 2x plus 5? Because I could have written 2x plus 5 equals 3y, but I like to have the y by itself on the left because it's really looking like y equals mx plus b. Had I taught you right from the beginning, the equation of the line is mx plus b equals y, then we'd be doing everything backwards. Which is not wrong, it's just how we say it. Okay? So now how do I get y by itself? I need to divide this side by 3, which means I need to divide this whole side by 3. When you divide this side by 3, you just get y. This whole side by 3 means that the first term is divided by 3, which we'll write as 2/3 x. The second term is divided by 3, which is 5/3. And now that we've changed it to y equals mx plus b, we know that the slope of our green line is 2/3. We had to do all of that work to find the slope of our line. What will the slope of our line be? over 2, because it's perpendicular. I'm going to put this green work inside of a green box, because that's all to do with the green equation, and now we don't need that anymore. We just needed that to find our slope. The point is a little bit disguised. It says it has an x-intercept of -6. So we weren't given the point in its normal coordinate form. How would you write an x-intercept of -6 as a coordinate? -6, -0. That's not a y-intercept, so that's not. Just be careful. Why is that not b? What does b stand for? Y-intercept. This was the x-intercept. See yourself getting tempted to use it as the b value, but that would not work. So they want this one in the slope-intercept form. So we want it in y equals mx plus b. You know the m value, right, was -3 over 2. You can plug that in. We know that when x is -6, y is 0. How do you multiply fractions? Right? Multiply the tops, multiply the bottoms. Can you see that this would be 18 over 2, which reduces to 9? If I wanted to get b by itself, I'd have to subtract 9 on both sides. And now that we have our slope and our y-intercept, we can write the y equals mx plus b form completely. So the idea that we've been doing now for like 3 or 4 classes, find the equation of the line, does not change. The only thing that changes is how they disguise the 2 things that you need. You need the slope, you need the point. This one was the hardest way they can disguise the slope. I don't think it will get harder than this. Okay? The point, sometimes they give this, the point can be disguised a little bit more than this, but not too bad. Okay? Again, everything will be given in the question as hints for those 2 things. You have questions? So, was everybody done with the last one? Good? Okay. Find the equation of the line. So, as soon as I see a find the equation of the line, I'm telling myself, okay, I need a slope, I need the point. Let's see how disguised they are on this one. Parallel to this one. And passes through the y-intercept of that one. Is the slope disguised? Yeah. Yes. So I'm going to go to green here. We need to change 3x minus 5y plus 7 equals 0 to y equals mx plus b. If I do that, can you see that it would make sense to get the y by itself by adding 5y? I'm going to just write that 5y here on the left. Divide everything by 5 to get y by itself. We do all this work just to find the slope of our green line. How does that help us? What's our slope going to be? Also 3 over 5. Because they're parallel. They gave us another line. I'm going to make this the blue line. It says it passes through the y-intercept of this line. So for the blue one, we need to find the y-intercept of negative 2x plus 7y equals 14. What is the algebra way to find a y-intercept? Right. If you have a y-intercept, you know the x value is 0. This should be automatic for you. When you hear y-intercept, you're like, the x value is 0. When you hear x-intercept, you're like, y value is 0. Makes sense when you think about drawing them on your graph. Algebraically now, this equation becomes easy. If I plug in a 0 for x, how's your 0 times table? Pretty good? That's negative 2 times 0. Oh, good. Someone's been practicing on the holidays. So then we just get 7y equals 14. How do you get y by itself? Divide both sides by 7. So we get a y-intercept of 2. Okay, I'm going to put a blue box around this one. Because we needed to do all that work just to find that point. How does that help us with our point? It's going to be and this happens to be the y-intercept, which is your b value. So we did all of this work to find the slope that we needed and our point. Now that you have your slope and your point, I'm going to do it in y equals mx plus b form, and this is going to be really quick because we know the slope is 3 on 5. I don't even have to plug in a point because I know that my y-intercept is the b value. It's equal to 2. The answer was really quick once we found the two things that we needed. Right? But both of them were disguised this time. The y-intercept was disguised, and the slope was disguised for it. What's exciting about the next question? What's also daunting about the next question? It's the last question. Exciting because we're finished the unit, but what's not exciting about finishing a unit? The test, yes.
Monday. Test on Monday.
Okay, we'll discuss it once we're done the last one. Do you want to try the last one on your own? No? You want me to do it with you? Okay. Alright. Find the equation of a line. So same as always, we need two things. We need a slope and a point. Did they give us either one? No. Did they disguise both of them? Yes. It's perpendicular to the green line. Now, in the first two questions I wrote out, you need to change to y equals mx plus b so that you'd have that in your notes. If you were doing this on a test, you could just start changing to y equals mx plus b. So I would add the green line. Can you see I could add 5y to both sides? Then if I divide everything by 5, I would get my slope to be 3/5. So when you're showing your own work, we don't have to write down as many words. That's the part where you have to understand that, understand why you're doing it. We wanted to change this to y equals mx plus b so we could get a slope. Our slope then, we can now write down, is going to be -5/3. Did they tell us the point directly? No. They gave us another line. I'll make that my blue line. It needs to have the same x-intercept. How do you find an x-intercept? Plug in 0 for y. Again, I'm not writing it out this time. I want to get x by itself. I'd add 18 to both sides. Divide both sides by 3. So I have an x-intercept of 6. How do I write that as my point? 6, 0. I'm going to make this point x1, y1. I'm going to use y minus, point slope form, y minus 0 equals negative 5 over 3. X minus 6. Distribute. I multiplied the 5/3 by the x and by the negative 6. We have fractions, do we not? General form has no fractions, so I need to multiply this whole thing by 3. Y times 3 would be 3y. This times 3 will get rid of the fraction. This times 3 will get rid of the fraction. Can you see, I could have simplified 30 over 3, and I would have gotten 10. And then I would have to multiply by 3, and then I get 30 again. So I didn't simplify it because I knew when I multiplied by 3, it would just cancel that 3 out on the bottom. But you could have. Is this in general form yet? No. We need one side equal to 0. Can you see that my value in front of x currently is negative? So I'm going to move everything to the left-hand side. I'm going to add 5x to both sides. I'm going to subtract 30 on both sides, leaving me with 5x plus 3y minus 30 equals 0. Circle that as my final answer. And we are officially done this unit.